In this video, I'm going to do an integration question from the IB Math SL exam. So we're given the derivative of function f prime and asked to find the original function f of x. This is a very common application of integrals. They also give us a specific piece of information that f of 0 equals 1, and that's the last thing that we're going to use when it's time for us to find the specific c value. So we're going to start by setting up our integral of the function, and don't forget to put a dx next to it. And then we're going to look at it and decide what kind of integration it is. We can't just go term by term because we see that there's division in here. So when there's quotient or a product in your integral, we're going to want to try to use substitution. So I recommend that you first separate the quotient so that you can write it as a product of the numerator times the 1 over the denominator. This is just going to help us identify a little bit more easily when we've chosen the right u. We want to try u substitution. If you're not sure what to make u, you can just take a guess and see if it helps you. So I'm going to let u equal x cubed plus 1, which is the inner function that I noticed there in the denominator. And then I'm going to check. So when I do du dx, which is the derivative of the u I just picked, I get 3x squared, and then it would be plus 0, which I don't need to show. And sure enough, when I check out the integration I'm trying to do, I see there's a 3x squared there, and a dx is the only other remaining factor. So if I pass this dx over here, I see du equals 3x squared dx. And now I have something I can substitute in my integral for each piece of it that's all going to be in terms of u. So I can see that this, in fact, let's stay as red for a minute. This fraction is 1 over u to the 5th power, because that's what I define u to equal, and it's raised to the 5th power. That's something I feel like I can integrate. And then the rest of it combined is du. And then I have to remember that I still haven't integrated. So once I've accomplished choosing the right u, doing the du dx, seeing if that helps me, and rewriting the whole integral in terms of u, don't forget to integrate. I have plenty of students who get this far and think they are done, and they change u back to x cubed plus 1, which we can't do at this point. This is the whole point of getting it all in terms of u is to integrate. So think about it as the integral of u to the negative 5th power, so that you can integrate using your power rule. And now we're ready to integrate. So we're going to have equals, increase the power by 1, put it over the new power, and put a plus c because it's an indefinite integral. I could change the u back now, but I think I'll just clean it up a little bit first and put that u to the negative 4th on the denominator as u to the positive 4th. So this will equal negative 1 over 4 times, I can replace the u now that I'm moving it to the denominator, plus c. And that equals f of x. I just moved the negative up to the top in case that was confusing, because I didn't want to leave it on the bottom with this 4 right here. So this is my function f of x. When I had the original function was f prime, and I finished my integration, then that's f of x. But this is an infinite number of functions because that plus c could be anything. So this is when I use the other piece of information they gave us, which is that f of 0 equals 1. So we have a specific input and output that must exist on this function. So if I put that in, that the function has to equal 1 when x is 0, I'll see that now there's only one thing that c could be, because I'll be able to solve this equation for c. So I continue, simplify this fraction, it's going to be negative 1 over 4, and I add 1/4 to both sides, and I get that 5/4 equals c. Now I'm ready to write my final answer, which is the function f of x, which equals negative 1 over 4 times x cubed plus 1 to the 4th power, and then the whole thing plus 5/4. And you could go one step further to try to get a common denominator and add these two fractions together, but the mark scheme does accept this as a correct final answer. And that is all.